Okay, so we're going to talk about Python, and this is all documented on our website. So I'm just going to pull that up here. And we have, just so you know, if you go to research-it.upenn.edu, we have high-performance computing documentation, the basic stuff, and we also have a page for all the different tools. So usually most of the solvers, compilers, software packages, programming languages, we have a link over here that will tell you specifically some tips and how to work and do examples with those languages. And today we're going to talk a little bit about Python. So I'm just going to run right down through this. I'm going to pull up my, I'm logged in the HPCC here, and we're going to create a job script. Well, so first, I wanted to talk, so a job script is just like the MATLAB one. It's a bash script. It's named whatever job name. We join the output. Otherwise, if you don't join your output, you get two files. You get an E and an O. And the E is the errors and the O is your normal output. And if you don't join them, it's kind of hard to tell what came first in what order. So it's a lot cleaner just to have one file. Let's see here. So on HPCC, the default, it's based on Red Hat Enterprise Linux 7, and the default Python interpreter is Python 2, which has been deprecated. It's older, but it's still built into the operating system. So if you want to use Python 3, we have a few commands to run here. So I'm going to go ahead and I'm going to go to a Q login. We do not allow code and IO intensive stuff to run on the login node. So before you do any of that, please do a Q login. And that should get me a shell on one of the compute nodes. There we go. So I'm on compute node 11. And you can see, let's see, how many of those are there? Yeah, we have some newer versions, Python 3.6 is our latest version here. That's
actually, can I interrupt just for a second about versions? We do have Python 3.8.5 is our latest.
Oh, okay.
That's done with module though, instead of, because there's no Red Hat version.
Gotcha. Okay. I'm just going to go ahead and do these ones, and then if people want something more recent than 3.6, just let us know and we can send you those commands. So if you want to work with, say, here I'll show you, Python, cruddy, ancient 2.7, no thank you. I'm going to use, I want 3.6. There we go. Yay, 3.6.9, great. Let's say our project, oh, did I even finish? I don't think I finished. I got distracted with the get with the get. So anyway, yeah. Just a quick view. So if you were to make some changes to this file on Git, build electric. Every time you make a change, it shows, and you can do get diff and see the changes. And you can do commit add A, add M message. There we go. So let me see what we got. Theme. Got our to-do list. Yeah. So yeah, so on and so forth. You could have 1,000 changes, and you could back up and undo and go to any version of that. So you can see the Git, so on and so forth. Anyway. Okay, back. CD sum project, my project directory. So I'm going to say in here I want to keep what is called a virtual environment. A virtual environment is a self-contained directory that will keep a reference to the to the Python modules, and it will contain all the code and all the libraries for those modules. So you're able to make a stack of Python modules for a specific project. And you can have, you can create multiple virtual environment directories, and anytime you want to run a different piece of code, you can use the Python virtual environment that you want. So you can have a completely different stack of modules in each directory and pick which directory you want to use every time you run. So right now I'm just going to create one, and we are going to use the virtual env command. So I'm going to do I'm just going to call it env. So this builds a directory and makes links and all kinds of scripts in there that we can then so then we can enable it. Oh, sorry, we got a source. Activate. I'm sorry, activate it. So there we go. We can see that we are using environment A because our prompt has a nice little env begin. And we can see we're using this Python interpreter. There's also a link underneath of the environment name. And since we've enabled Python 3.6, we're getting the latest Python. And we can do, one of the first things I recommend you do when you create an environment is to do a pip install pip -u for upgrade. So let's say, I don't know, you want to use something, you want to use a module like Python fuzzy wuzzy. So we see that there's this, oh look, hey, there's a pip command for installing fuzzy wuzzy, great. And just fuzzy wuzzy is a method for fuzzy matching strings to each other based on mathematical distance. It's great if you've got kind of some messy data and you want to like find things and match them based on a score. So I'm just going to do this. I'll do a pip install. So for this project in this environment, we want to pip install fuzzy wuzzy. There we go, installed. So yeah, and then we can start using it. So it's an example here. Yep. From fuzzy wuzzy, import fuzz. Oh. Oh, okay, warning. We got a warning here that pure Python is slow. So we could have installed this extra package to make it a little faster. I'm going to skip that. That's interesting. So right here, we can figure out what the ratio of difference is between these two strings. 97. That's interesting. And the more single character changes there are to these strings, the lower the ratio goes. So that's cool. We've got a module. It's in our environment. And you can just exit out of this or deactivate if you want to switch to another one. We could also make another virtual environment if we had. I typically like to have a virtual environment per project. You might want to create a whole another virtual environment just to try the newer version of the modules or a different version of the modules. And so you might create environment B and build your stack in there and use an old version or use some kind of new. You can mess around with that. You can try like say like, oh, this is awesome Python module. I think we should be using this. I think it's going to be more efficient and it gives us all these other options. You could create another virtual environment, leaving the old one that works alone. You could branch your code. You could try using that in your code, and you could install those modules and use them in environment B without ever having touched your environment A. So that's a good way to have like an undo button or like another copy that is not, that you get a whole other playground to play with that you don't have to worry about breaking. So yeah, that's that's about the gist of that. Now, oh yeah, I should mention that when you write a script that uses one of these virtual environments, make sure you do those same commands. In the top of the script, the first command should be your oh, hold on, I just lost it. You want to enable the newer version of Python. Where is that? You want to source enable your version of Python that you choose. So that will be your first command in your scripts. And then you want to source and enable and activate your environment of choice. So there's two things you need in your script if you're using a virtual environment: your Python version enable and your virtual environment activate. And then after that, you run your Python command with your code. So that is that in a nutshell. Are there any questions about that?
Talk about what happens when you use Git right now on your directory.
Aha, okay.
Or show.
Yeah,
anyway.
so yeah, I made the mistake of, I put my entire project directory in Git. If I wanted to,
it's not a mistake necessarily.
Yeah,
that's what I do.
So if I can see, I actually haven't added the file, so it's not a problem. But if I were to add and commit changes here, it may subsume the whole virtual environment and all the libraries in there, and that would be pretty messy. If I just want to see like the actual text changes in the file when I'm browsing the repository and get a Bitbucket, I don't want to see like thousands upon tens of thousands of code that's been imported from some off-the-shelf module. So that's not something I want. So I could either not add that directory, ignore that directory, or just don't get init at the top level of my project. Only say like, I'll make a dir called code. And in code, I would have done my get init. But instead I did the top. So no harm, no foul. There's ways around that. Just depends on how you want to work it.
What's a good shorthand way to keep track of the modules in your Git repo?
Oh yeah, sure. Okay. I think, let's see. So yeah, if we activate, I need to activate our module and source, and then activate. Okay, I'm using NV again, and you can do pip freeze. Pip freeze will show you, it will print out a list of every module in the environment and equal its current version. So a good thing to do is in your code directory, do a pip freeze and pipe that output to a file called requirements.txt. This is pretty standard in the Python world. So now your code comes along with a list of the exact versions of the modules that work with your code. So keep that with your code. So you'd want to do a git add. There you go. So you've got, then you can look at that. You can see all of our changes in the log. So yeah, that's a good point, Hugh. Thank you.
Yeah, you might hear from your PIs, your faculty, reproducibility is extremely important. This is the way to get reproducibility. Without it, there's a potential for disjointed. That's also a way to send to the other users, make my environment exactly like yours.
That bit me yesterday, Hugh. You know it. I went to rebuild I wanted to run a code on a different computer because they upgraded the server and and it was all new. It was all new, so I had to install a new environment. And when you pip install, it installs the latest version. But I hadn't done that in like 3 years. So everything broke and nothing, it was all like deprecated and like different ways of doing things. And so luckily I was able to go back to the old server and the old directory and do a pip freeze to the requirements file, add that to Git, and then when I did a pull, the requirements file is there, and then you can do like, I think it's like pip install -r.
Yep, -r, yep.
Yeah, and that will install all the versions that are in that. Yep. all the versions that are in there. So that's a good way to have reproducibility in portable code. Very important tip. All right. Any more questions before we move on?
Yeah, maybe this question is too specific, but in Python you can use like a map, right? So that give you some multi-processing utility. I'm just wondering, like, if we just submit, like a normal job to the server, so it's like only giving me like a one core, I guess, one node. Does that also enable the multi-processing of it?
Yeah, good question. So if you've enabled some multi-processing, or you're spawning other threads or other processes, and you want to use, say, like 4 CPUs, if you just submit the code, we enforce binding, you only get 1 core. And then those 4 threads will fight for each other, which is not efficient. So what you want to do is use we have a page about this, but it's like, it's something like Q sub -PE, parallel environment. And for multiprocessing, you want open MP for multiprocessing. Not open MPI, which is message passing interface. You want open MP, and then your job script. Oh, I forgot that. So if you wanted 4 cores, you put a 4 here. So that's how you would do that. And I believe again, in user local demo, we have a, do we have an MPI? Yes, we have a benchmark. I'm not seeing an MP version.
The R one has a good example of that. But basically, you need to make sure that, like, a lot of times, if you're using a module that uses threading like that, oftentimes what it does by default is look at the number of cores that are on the box and launch that many threads. Oftentimes, it even says that in the documentation, get number of cores, and it will be 16, and those 16 will be running on 1 core. So you need to set it manually to the output that you put, the number that you put in that OpenMP thing. And there's actually an environment variable, all capitals, N slots. N slots. I wrote that in the chat. But if you're trying to do that stuff, let us know. We can just sort of double check that it looks right. It can be tricky. Okay. Also the number of cores. Our boxes have 16 cores. If you request 16 cores, it might take 2 weeks for your job to start. That means a whole box has to clear out, which is very, very, very hard in our environment. So 4 is a good number. 8, it's not super busy right now, so you'll probably start in, half an hour or 20 minutes. If it's a 30-second job and you're trying to get it 8 times faster, just do 1 core.
Okay, thank you. I thought there might be like some trick I can use, but maybe a bit harder to implement.